There are several hidden relationships in circles. This video discusses relationships between central angles, arcs, and chords. We'll also start seeing why circles and triangles are related as well. Let's start by talking about the congruent central angles and arcs theorem. This tells us that within a circle or within congruent circles, congruent central angles have congruent arcs. In other words, if angle AOB is congruent to angle COD, then arc AB is congruent to arc CD. For the proofs, I'm just going to quickly go through an outline because we don't have much time with these videos because there are so many theorems. This one is easy to prove. Remember that congruent arcs have two pieces to them, congruent measures, and since we're given that the central angles have the same measure, the arcs have the same measure, check. Then the other part is equal lengths. And because we're in the same circle or congruent circles, that means the radii are congruent. So if we're plugging in the same arc measure and the same radius length, then we're going to come up with the same length for both arcs. Therefore, the two arcs are going to be congruent. The converse of this is also true. Within a circle or within congruent circles, congruent arcs have congruent central angles. In other words, if arc AB is congruent to arc CD, then the measure of angle AOB is congruent to the measure of angle COD. And we're going to do this in exactly the opposite way, except for the fact that it's going to be even faster, and that is, since the measures of the arcs are the same, the measures of the congruent angles have to be the same by definition. Our next theorem is the congruent central angles and chords theorem. This says within a circle or within congruent circles, obviously the radii need to be congruent, congruent central angles have congruent chords. So if we look at a figure here, that says that if angle AOB is congruent to angle COD, then segment AB has to be congruent to segment CD. Again, the proof of this is going to be pretty straightforward. Notice that segments OA, OB, OC, and OD are all radii and therefore congruent. And if they were in congruent circles, they would still be congruent. So can you see how triangle AOB and triangle COD are congruent by side angle side? Therefore, corresponding parts of congruent triangles are congruent because of the definition of congruent polygons. The converse also works. Within a circle or within congruent circles, congruent chords have congruent central angles. So if segment AB is congruent to segment CD, then angle AOB is congruent to angle COD. Again, this is very easy to prove, because once again we have all of those radii that are going to be congruent. So the triangles are congruent by side, 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 and therefore the central angles are also congruent by the definition of congruent polygons. And our final theorem for this video is the congruent chords and arcs theorem. It says within a circle or within congruent circles, congruent chords have congruent arcs. If segment AB is congruent to segment CD, then arc AB is congruent to arc CD. This is just a combination of the two theorems that we just learned, and so therefore it's really easy to prove. The proof is really only a couple of steps. Since the chords are congruent, the central angles are congruent, and since the central angles are congruent, the arcs are congruent by the two previous theorems that we just learned. The converse, of course, is also true. Within a circle or within congruent circles, congruent arcs have congruent chords. So therefore, if arc AB is congruent to arc CD, then segment AB will be congruent to segment CD. The proof, very simple. The arcs are congruent, so the central angles are congruent. And since the central angles are congruent, the chords are also congruent by the previous two theorems that we learned again. So let's try this. In our figure, we know that circle C and circle Q are congruent, and that segment DR and segment EG are congruent. In other words, the two chords are congruent. So what can we conclude? Well, if the chords are congruent, we can conclude that Angle C and angle Q are congruent by the converse of the central angles in Chords' theorem. And we can also conclude that the arcs are congruent. Arc DR is congruent to arc EG. And we can either use the congruent central angles and arcs theorem, or we just learned the congruent chords and arcs theorem. Either one will work now that we know that the central angles are congruent. Easy enough? You try some.